get started, even as people are showing up, I want to say welcome to the session, and I hope you are enjoying the class so far. I do see a lot of activity in the discussions, and that's just wonderful, and I will be therein as well, responding to your posts and asking you follow-up questions just to have more information that we can explore and learn. It was a pleasure to meet all of you who showed up to the office hours on Monday, but that is how it will be for the whole semester. Office hours on Monday at 6 p.m. your time, and then the actual live formal presentation on Wednesdays at 6 o'clock your time. So it's a good idea, again, if you could start reviewing the material early in the week. So if you have questions, you can either ask them at the office hours or ask them during the live presentation. When I continue with the live presentation, I will go over some of the material that you read over the week or during the week for that week, and also describe the assignments that you have. But this week we're pretty much just getting familiar with the classroom, getting familiar with operating systems. If you noticed in your readings, it kind of was an introduction to many aspects of operating systems, and your discussion question was to describe the operating system, to describe some popular operating systems, and also to describe the kernel. So I hope that gave you just some familiarity now with what an operating system does and some key terms. I also want to just kind of recap what we will be covering in this course. So there are a lot of topics that we will be covering, and also there will be some programming that we will be doing. This is something I did mention in the office hours. So do make sure you use your Java, have it installed, ready to go. And we will also be using what is known as a virtual machine so that we can simulate our programs that we create in Java and simulate some of the functionality of an operating system. So I will give you more detail on that. That is later, about mid-session. But so far, do any of you have any questions? So I'm hoping that you're able to get the material, view the videos, view the PowerPoint presentations, and read the book. So I think you're all wonderful students, and I think you're very dedicated to your learning, and that this will be great information that you will be able to explore. I noticed in your introductions, a lot of you are very excited to learn this material. Some of you have a passion for it and want to carry this further. As I mentioned in the office hours, this is some basic material that no matter what you do with computers, you need to know. Even if you're maybe creating web pages, or you're programming applications, or you're just an IT professional, maybe in an administration position, you need to know all about the fundamental basics of operating systems. So you're in the right class to learn all about it. So these are the topics that we're going to go through. Computer and operating system structures pretty much is what we're going through this week. Then this is pretty much as the course carries on. We'll be looking at processes, threads, synchronization, communication, memory management, virtual memory, file system management, input-output management, device management, and so on. If you notice the term management, that's what an operating system does. It manages a lot of the items that are associated with your computer. As for the assignments, I think you already are familiar with how to access assignment, how to know what you need to do. For this week, we have a discussion question, so I ask that you get it answered by today, and also to reply to your classmates. As I mentioned in the office hours, the more you work and collaborate with each other, then the better the experience is, and you can share information with each other. I am sharing information with you as well. Also, if you find some good links or references that you want to share with your classmates, because maybe it helps you understand better the topics that you are learning, bring it to the discussion forum. This is your area that you can work with each other. Also, if you have any questions, feel free to bring them in the discussion area. And then I, or your classmates can help you and answer it. And it's just a better learning experience. So do answer the discussion question. Do reply to your classmates. Some weeks you will have lab or programming assignments. Those are always due at Saturdays. We will always have this live class on Wednesdays. And then your exams, the midterm exam is week 8 and the final exam is week 14. And the exams are pretty much based on the textbook. So everything you read and learn in the textbook will be on the exam. The discussion question allows you just to explore some topics and look at some links and videos. And the programming assignment gives you some hands-on for some of the topics, but not all the topics. So you are responsible to know all the material in your textbooks to prepare for your midterm and final exams. At the end of every session, I will have a list for you of the topics. So a good way to study for your midterm or final exam is to take this list and then look at the topics and then write down a little summary and some brief description about that topic. And that will help you then prepare for the exams. This is how your grade is calculated. So your assignments are 20%, the midterm exam is 30%. Attendance in this area here in the discussions is 10%. So you are required to come to this live session and you will get points for coming here. If you don't come here, then you will not get those points. And then the final exam is 40% of your grade. So if you see your exams, if you add it up for the midterm and final, is 70% of your grade is in the exams. So that's why it's very important for you to start early in reading your textbook, looking at the videos, and looking at the PowerPoint presentation so that you understand it. And you should make notes of the material from the textbook so it'll help you then to be familiar, to know where the information is, and all the definitions and the descriptions. And again, I'll give you a list every chapter so that you have something then to use, like a checklist, to make sure you understood everything you read in the textbook. Does that sound like a good plan? Does that help you? Okay. Okay, so far, hopefully you're already doing the work as you should. And discussions. I do say that the more you, first of all, the more you go to the classroom, the more involved you feel, the more time you have then to look at some of the textbook, or look at the videos, or look at what I post, or look at what your classmates post. It's a good way for you to research the material and understand it better. A lot of your answers are just wonderful. All of your answers were wonderful on the discussion already. So I know you are wonderful students, and I think you're going to do very well in this class. And just keep doing what you're doing for the next 14 weeks. And then you'll be great operating system professionals. And as I mentioned, your lab and your programming assignments you're going to be using. Yes, I will give you the slides. I will post it. I can add it to the discussion forum. So where we post, I'll put it in the classroom or on the announcement. So I will give you the slides. Good question. So the lab and programming assignments, as I mentioned, that you're going to be using the Java programming language, and there is a virtual machine, which there is one that you can download, and it's described in the textbook. That might be the one we use, unless the school has something different. So they are working on that to determine which way this class will go. So I will let you know as soon as I know, and I will give you all the information you need so that you can successfully then complete your lab and programming assignments. And the exams, they're given as scheduled. Again, midterm is week 8, final exam week 14, and all the information that you are discussing, exploring, or assigned in the class assignments are material that is covered on the exams. And again, the exams are 70% of your grade. So good strategy, again, I'm going to give you these lists that you can use so that you can know all the different topics from each chapter, and then write it out, you know, or have another area where you take notes so that when you start studying, you'll have all these notes that will refresh your memory. Because by the time the midterm comes, we're already going to be several chapters down the road. So this way you can go back then to start and reviewing chapter 1, 2, and all the chapters that are on the exam. So keep your notes now. Every time you go through a chapter, look at the list of the topics, and then you'll have all these lists for you with all the information that you wrote, and you could use that to study. And some successful strategies. The more you visit the classroom and look at the material, you know, the more opportunity for you to learn. And I will be posting announcements, discussion posts, email, so look for that. Look for it every day so that if I have something new, you will see it. Attend the live lectures. Read all the assignment material that you are assigned and complete the assignments on time. If there's discussion questions, that's by Wednesday. Everything else by Saturday. And then look at the assignments early in the week so that if you have questions, then you have time to get them answered. And you can put your questions in the discussion forums, or you can email me. Whatever works for you works for me. I am there to help you. And help your classmates. Again, post with your classmates. We're like one big happy family working together and helping each other. So that'll be a better learning environment, and then you will actually have fun while you're learning at the same time. So hopefully these are good strategies you will follow. If you haven't done them before, this is your opportunity to do that. And this is a wonderful topic you're learning. Again, I can't stress this enough. No matter what you do with computers, you have to understand operating systems. So this is important information. Okay, so what is an operating system? Wonderful definitions. A lot of you have already put into the discussion, so everybody read each other's definition, because the more you read it, the more you understand it. You see, seeing the same information and maybe with a little bit more detail, and then it just gives you a better understanding. But it's a program that acts as an intermediary between a user of a computer and the computer hardware. That is something all of you already learned. I saw that in your definitions in the discussion. And what are some of the goals for the operating system? Well, it needs to execute the user programs and make solving user problems easier make the computer system convenient to use, and use the computer hardware in an efficient manner. So we're going to be learning at all the components of an operating system, all the items that it manages or it works with, and then we will be looking at some of the strategies it uses. It all depends what kind of hardware you have as to what kind of operating system you will need. Some computers work differently, so they'll need a specialized kind of operating system. Some of them are general purpose, so it needs a basic operating system. So there's a variety of operating systems out there because there's a variety of computer systems and hardware. And they have to match. In order to use a piece of hardware, you have to match it to the correct operating system. So the computer system structure, and it can be divided into 4 components. There's the hardware. The operating system, which is also known as system software, runs the hardware. And then you have the applications, programs. Some are what users create to use and apply to real-world problems and scenarios, such as running a business or running a website. There are some application programs that help you with the operating system so that you can use your files. You can see your files and your folders, all the information or storage you have on a computer. Or you can change the volume on your microphone or change the volume on your speaker. This is the user's interaction with the operating system. What we tell the volume for that microphone, then the operating system will make sure that microphone is turned up to that volume. So it's all of these work hand in hand, and this is what we're learning as to how an operating system makes this possible. Again, the 4 components of a computer system. Here's a picture of it. But typically, this kind of gives you an idea of all the areas an operating system manages. The operating system manages the users. When users are there, it has to be able to talk with the user, understand what the user is doing, and if there's more than one user, make sure they can tell the difference between one user and another, and make sure that they do what each user wants and doesn't jumble it up or confuse them. You don't give the results to user 1 what user 2 was doing. It has to keep it all organized. And then it manages the programs, such as databases or database systems. So it has to manage it. When a user wants to look at some data, that operating system then has to make sure that that database program is working. And then when a user types on the keyboard, that it goes to the database and not for some reason just to the screen. So there are a lot of applications, there's a lot of programs, and there's 2 categories. We have systems, programs that are written to work with the operating system. That's why they're called systems. And then applications. These are applied programs. They're applied to the real world. And then the operating system has to manage the computer hardware so that you can use it. Any questions so far? These are some basics. And anytime you use a computer, just look at it, what you are doing, and then think, okay, what is the operating system? How is it helping you do your job? You know, when you type on a keyboard, what is it doing for you? When you're speaking to the microphone, what is it doing for you? What is the actual steps and processes? It's not magic. There are steps. You press on a keyboard or on a key, there's a signal That signal then is sent, and the operating system has to figure out what that signal is. When you start your computer, it's called booting up your computer, or bootstrap program. These are one of the basic things an operating system does, because it needs to already load some instructions into the computer so that you can start using it. When a computer is booted up, there's several steps that are followed. There is a chip that has written on that chip some instructions, so that when that computer is turned on, the electricity goes on, those instructions are automatically processed. If you ever do start your computer, sometimes you will see some stuff on your screen that automatically happens. That is because it's on these chips or firmware. In other words, they're actually put into that chip and can't be changed. But it's needed. It's put there because it's needed to start your computer. It'll also do a test. There's a test that's done. And it goes, what the test is, it goes through to see what's all the hardware connected to your computer, so that it knows then what programs it needs. Is there a keyboard? Okay, it's got to make sure it has the keyboard device driver. Is there a monitor? Then it needs the monitor device driver. Is there a printer? Then it needs the printer device driver. So it does this test to see what everything is connected and make sure then the appropriate programs are in memory to start processing in case when you start using these devices. And then after it checks everything to see what you got, it then loads the operating system kernel. And then it ends up to the point where it loads up for that screen that comes up that you then can enter in your information or do whatever task you want to do. So there is a process. All of it is stored on these firmware, on these chips. There are specific tasks, and there is a sequence of tasks that occurs. And some of the operating system gets loaded into memory so it can be processed, and some of it stays in the storage device, because you don't need all of the operating system right away. It will wait for you in case you need a different program. And also, operating systems are very large. If it were placed in memory, then you wouldn't have room for anything else. So do make sure you know how a computer boots up. There is information and diagrams in your textbook. Also, if you want to know more or you want to hear about it and look at it in a different way, then look on the internet. And there's a lot of websites that are out there that offer you information and pictures for you then to understand this process. Any questions so far? All right, you guys are all good. If you have any questions, just type them in the chat box. Even if I'm talking, don't hesitate. Again, you have to know this, and I'm here to help you to know this, so make me work to help you learn it. Now, another process, interruptions. Interruptions is how signals are sent to the operating system. It kind of tells when, okay, somebody pressed the keyboard key. So the operating system is sitting there. It might be doing something, it might not. And then a key is pressed. So that key press will then interrupt the operating system, in other words, and say, hey, I'm here. I was pressed. There's no signals coming in. So the operating system works with all these interruptions. And depending on the type of interruption, it then knows what to do, or what it should do. And it looks to see who's giving this interruption. Again, if it's coming from a key press, then it knows it needs to do something with the keyboard. You know, if it's coming from, you know, another device, then it knows it needs to work with that device. So the operating system is there. It's always ready to do what you're going to ask it, but it doesn't know when you do, so it's just sitting there idle and waiting. And then when something needs to start going, it'll kind of interrupt the operating system and say, hey, I'm here. I need your help. We need to do some stuff. So it's all based on these interruptions, and there can be different strategies for these interruptions. And depending on the type of interruption, we'll determine then what instructions need to be processed. So it's a good system. Everybody's pretty organized. The operating system's organized. It pretty much knows what to do when it needs to do it, because all the programs and code is already written. It just needs to look up the right program to start processing. And everything has codes. So it's kind of looking at this code and saying, okay, this code means I need to do these instructions. And then it continues on and does the job. And these interruptions, I did mention again in the office hours briefly, but it's all based on signals. There is a little clock, and every time that clock ticks, then the next set of signals are let through. So it's a ticking clock. Every time it clicks, gates are opened or gates are closed. It's all based on electric circuits that have gates. If a gate is closed, that means signal cannot go through. If a gate is open, that means the signal goes through. So the operating system and the programs will determine which gates are open, which gates are closed, and every time the clock ticks, then there's a new set of gates open and closed. And depending on what is done will determine which gates are opened. For example, if you need to print something, then the gates to the plug that goes to your printer or the port, that's where the gates are open, so the signals can be sent out that port and then travel to your printer to then do your printing. So is everything okay with that? Do you have like an idea or a visual thing as how the signals run through your computer? And I did mention this briefly also. We're talking about bits. We're talking, first of all, the computer works on signals, zeros and ones, which means 0, the gate is closed, there's no signal. 1, the gate is open, the signal is there. So the 1 and 0 is our way of working with signals or no signals. We can type 1s and 0s. So when we program, we can type words that get translated to 1s and 0s. And it's these 1s and 0s then are further translated then into electrical signals. So these are important groups of 0s and 1s. There was organization done so that our world can be represented into our computer, which means all our letters, for example, whatever you use for your characters, 1 byte is 1 character. 1 byte is a series of signals. So that's how we can use the computer. Even though all it understands is signals, we can use it for our letters and words, which means it translates it. So there's really a bunch of tables. The operating system works with many tables with all these different patterns of 1s and 0s. And then it knows, depending on what it needs, it goes to the table and gets the correct series of 1s and 0s, and then these 1s and 0s are translated into the signals. So that's how we can take our world, translate it into the machine, which is just a machine with signals. And then there's groups. There's larger groups. The bytes is the 8 bits. There's kilobytes, there's megabytes, there's gigabytes, there's terabytes. And some of those storage measurements are maybe familiar to you, for example, for how large your memory is or how large your hard drive is. They will be in these larger groups of bytes. So this does need to be known. When you are a systems programmer, you have to know how large things are, but maybe you've already experienced it when you try to maybe send your friend some pictures from the internet. Sometimes you know when it's too large, it doesn't go through because they might have a minimum of how many bytes it will allow. So this is similar. So this gives you a range, and then you have an idea of how many bytes that actually is. But it is something, if you're going to go into systems programming, you do work a lot with these organization of bytes. Some things will be in, kilobytes or megabytes or gigabytes, and you have to know that because you'll have to know how large is your memory to know how much you could put in there. So there's different areas of storage. We have main memory. I'm talking about memory. That's your RAM. One thing you should know, again, I mentioned to you before, you have a computer in front of you, your laptop. So look at it. We'll look at what are the sizes of your items on your computer. How big is your RAM or main memory? How big is your hard drive? What other disk drives do you have? What will they allow? How large is a CD? How large is a DVD? So these are just examples, and again, you will look at those bytes, and you will know exactly when it's 8 megabytes, actually you know exactly how many bytes that is. You just do the math. But one thing is RAM, or your main memory, is temporary. Everything else is permanent. And the reason why RAM or main memory is temporary is because this is what makes your computer general purpose. You can change what's in that main memory and then do a different set of instructions. You may have instructions for word processing one time. So that means you have a word processing machine. Or you may have instructions in there that is for a game. So now you have a game computer. So this is something that von Neumann, you've read about von Neumann, he was the father, they say the father of computers. But this is how the configuration came about to keep RAM temporary so you can change the instructions and do different jobs whenever you want and make your computer general purpose. There are specialized computers, sure, that can only do certain things and that's it. But the ones that you're using in your laptops are general purpose. You can switch it out. You could be a word processor one time, a database another time, a game another time, and so on. That's because memory or main memory or RAM is temporary. So do make sure when you go through your book, know the difference between RAM, ROM, PROM, EEPROM, EEPROM. So those are all various levels, and also look at what kind of RAM do you have. There's static RAM, SRAM, there's dynamic RAM, DRAM. Start looking, what do you have on your computer? That'll give you an idea as to what's common and what's being used now. And then the secondary storage is known as permanent. This is your hard drive or your CD drive, DVD drive, where you can store things permanently. And then there's even, if you're in the workplace, there's larger stuff, magnetic disks. A company that has 1 million customers needs to have larger storage capacity to store like a history of their company or a history of their business. They can't put it on a CD or a DVD. It's too large. So there are other types of storage equipment that are used. So every workplace, depending how old or new they are, will have these variety of storage devices, but at least know what's on your laptop. That's a good way to start, a good place to start. So look at how much RAM you have. Look at your hard drive. How large is it? What kind is it? Look at your CD or DVD drives. What kind is it? How fast is it? What kind of disks does it take? So it's a good way, again, to start getting familiar. And remember, the operating system manages all this. And you have what is known as a system program known as a device driver. Everything on your computer, if it's a device, has a little program called a device driver that helps run it. So start looking at what your device drivers are. What are your devices? If you are in Windows, you would go into Control Panel, System. The option would be System. There's something called Device Manager. Look at your Device Manager. And also you'll see that there's a Task Manager, there's a Memory Manager. Just as we mentioned, the operating system manages all these items on your computer, including you. How does a computer work? First of all, you have that clock that ticks and allows gates to be opened and closed. Any kind of instructions that the computer needs to process is in RAM. And then they are sent one by one to the CPU. The CPU is the central processing unit. Know what kind of CPU, what kind of processor do you have on your computer? How fast is it? Processors are measured in gigahertz. Typically, the processor works faster than the time it takes to get an instruction to it. That is most of the delay in a computer, is really the time it takes for that instruction to go from RAM to your processor so it can be processed. Processor is very fast. It's getting the information into RAM and then to the processor that takes the time. And we mentioned the interrupts. And we mentioned data movement as to the more the faster, right, exactly. You can have multiple, we'll look at that, multiple CPUs. You can have multiple or dual core, quad core. Okay, the more, when you have more than one processor, sometimes they split up the jobs, or they split up the users, or they split up the programs. Or sometimes they don't. They just each take an instruction and they just go down the line. Each CPU gets an instruction until all the instructions are done. And then again, this is the operating system that's passing and making sure these instructions are passed to the central processing unit. And it's the operating system that makes sure the instructions get into RAM so it can be passed. Now, central processing unit or processors sometimes have little bits of memory on themselves. They're known as registers. So they can even help maybe make it a little faster. They have some in their registers. There's some coming from RAM, so they can just kind of go through these instructions like an assembly line. The closer they are to the processor, obviously the faster they get there, the faster they get processed. The farther they are, the longer it takes. And if it's on the hard drive, or if it's on a DVD or a CD, that takes the longest, because it has to go from the hard drive to RAM, to the registers, then can be processed by the processor. And it's known as an instruction execution cycle. And again, this is all based on that clock. The clock is what determines then when the gates are open, so that electricity or instruction can move from one place to the next place. If it's on the hard drive, then it has to go to RAM. That's one clock tick. Then from the RAM to the register, that's another clock tick. And then the register to the processor, that's another clock tick. So it's all based on this clock and moves every time that clock ticks, and depending where it is, determines where it's going next. And again, the more processors you have, the more registers you have, so you can start loading the register and they get processed faster. Here is multiprocessing, meaning we have three. This is an example of 3 processors. And they all have their own registers. And cache. Cache is a term used for memory used for temporarily for a specific purpose. Okay. So now processors have even more memory on themselves, or storage area. So not only do instructions go into the registers, they'll go into the cache, they'll be in the RAM, and they may be in the hard drive. So again, the whole idea is to get it as close as you can to the processor to process faster. So now they started to put cache on the processors so that it even goes faster. So again, do some research on the processor you have on your computer. How many registers does it have? Does it have cache? Cache is a term that could be used in many ways. When it's cache on the processor, again, that's just some memory on the processor. You can have cache RAM, which means there's devoted area of memory that is used for a purpose. You can have disk cache. In other words, your hard drive, it has a group of memory used for a specific purpose. So a cache is just devoting resources to a specific purpose to help process something. So there's a variety of strategies used for cache. Some of it actually exists. They're actually memory locations. Sometimes they're virtual. And you'll be learning that as we go. Here we go, dual core. Again, look at your computer. You'll start looking at what you got. Do you have a dual core? Do you have a quad core? Those are some common ones now. So look at what you got. The more you look at what you got, the more you understand what is out there. Or look for advertisements. A good way to know about computers too is look for the advertisements for all the different computers that are out there. How are they different? You know, this way you can see all the different variations there are out there. Clustered systems, when you have a group of computers working together. So again, depending on what you have, what you're working with will determine what your operating system needs to do. And they are all specific for specific jobs. Now, process management, another area. I mentioned before, operating systems managers. So if you have any questions, you could stop me or type it in. I'm trying to get through most of this stuff, and we're getting close to the time, and I'm like only halfway through. So I will give you these slides. But process management, this is the management of jobs or processes or programs. So the operating system has to handle all this. And some strategies that it has to deal with is synchronizing, making things are working together. Deadlock. What if for some reason one program and another program are trying to get in at the same time? The operating system has to figure out which one has to go through first, or determine which one goes through first. These are some of the strategies we're going to look at when we do our Java programming. We're going to look at these strategies, how a simulated signal comes in, or two signals, and how do we know which one should go through and which one shouldn't. So we're going to look at this. Memory management, another area. Again, the operating system is a big manager. It manages your devices, it manages your processes, it manages your memory. When things are put in RAM, somebody has to know what's going on, and then when it finds it, if you need to find something that's there, how to find it. Storage. It's not magic when you create a file and you save something, it just automatically is there. There is operating system programs that make it possible. So these are all the various operating system programs. This is a graphic that's in your textbook, which is interesting if you like to know how fast things. I did mention everything in the computer is slower than the processor, so the processor always has to wait. But this gives you some idea where, depending on where something is, how long it takes to get to the processor. So something for you, again, to take a look at. And all the different environments. You have a standalone general purpose machine if you have your laptop. Portals, this is just some terminology for you to know and learn. You will need to know this on your exams. I'm sure you're familiar with networks around it. The internet itself is a large network of networks. But know the difference between a LAN, a WAN, a man in the pan, something that you need to know the difference of. Do understand what TCP/IP is. This is a common communication protocol. And what that means, remember, we just have signals. How does a computer know one signal from another signal? It doesn't. All it knows is patterns of signals. So it's a pattern of ones and zeros. And it looks at this pattern to determine what it is. So TCP/IP is a pattern of ones and zeros. So when the computer sees this pattern, it knows, aha, I'm working with a network. I see the TCP/IP protocol. Same thing for a web page. A web page has HTTP. You notice when you type in an address. Again, that's a pattern of ones and zeros. So when the operating system is figuring out what you want to do, it looks at this pattern and says, oh, I see HTTP. That means this is a web page. So that means I need to send it to the browser. So it's all these different patterns. That's how the computer makes sense out of what we want to do with it. Everything has a pattern. Everything has a protocol. And that is all stored in tables, and the operating system just looks up these patterns, and then with the pattern knows then what the next set of gates should be opened or closed. We have client server. This is where some of the machines are clients and some of them are servers. If you work on a network, you maybe will heard of servers. This is a way just so that every computer doesn't have everything. They figured, well, why should every computer have everything? Let's separate it. Some will just store everything, and then the other ones will ask for it when they need it. So you have file servers, you have database servers, you have web servers, it's all kinds of servers. And then you're all connected on the network, and you as a client will say, okay, I want a web page. So it goes to the web server, gets that web page, and sends it to your computer so you can see the web page. Peer-to-peer. This doesn't really have, this is the one that says like every machine is a client and a server. Every machine has everything. But every computer has everything, it's hard to control it. But a lot of services on the internet are peer-to-peer. If you download music or download movies, that's peer-to-peer. But you got to be careful with that because, again, there's no server. Since there's no really actual, one or two servers, nothing's really secure or controlled. Everybody can do everything. There's no delegation of tasks. So something to be careful of. Virtual. We're going to be experiencing virtual because we're going to be using a virtual machine when we're going to be doing our lab assignments and programming. A virtual machine is just a software version of a machine on an existing machine. So in other words, you can have one machine, but then I can have these virtual machines. So it looks like I have three machines instead of just one machine. So it's a way to, simulate a network, or simulate servers and clients. So we'll learn more about that as we go on. Again, this chapter kind of just introduces you to everything, and we will go back and learn more about these things as each chapter goes on. The cloud computing, this is another popular trend right now, because just like client servers are good, because why should every machine have everything? So let's put some stuff on servers, and then whenever you need it, then you'll be a client requesting it. It's a safe way to store it. It's a safe way to use it. Cloud computing now takes it to an even a larger scale. In other words, there are servers that a company owns, and you will put your stuff on their server. So you have software as a service, platform as a service, infrastructure as a service. So it's a way to have these things and not physically have it in your company. You're going to use somebody who has it for you, and you're just going to use their machines, their software, which makes sense because sometimes you don't want to pay for everything and keep everything on your computers. This way you could just use it when you need it. Real-time systems, these are those dedicated systems I mentioned before that only can do certain things. But real-time means they have, again, this is a different kind of operating system. Your operating system that you have on your laptop works with interruptions, and it sometimes can be delayed and wait. Real-time systems are running all the time and are ready for a signal at any moment and must do something right away. But they're specialized, as these examples show, for your vehicles, for traffic control, for medical systems, for computer games, multimedia systems, and household systems. So do know all the difference. Don't know the difference between general purpose and real-time specialized computers, as well as what happens when there's a bunch of processors or only one processor, and all the different types of structures or architecture such as client, server, peer-to-peer. So these most definitely you will have on your exams. Open source software, these are another group. Software that are free, you don't have to pay for. And Linux and Unix are the most popular ones that are these open source operating systems. So again, something you can experiment. Linux is used it is quite popular. Again, we will look at the different types of operating systems and also look at how they differ. But you can do that as well. You've already been doing some of that now when you answered the first discussion questions. You looked at what the different ones are. And then there's operating system services. We know that it manages devices. We know that it manages processes. We know that it manages memory. It manages files. So these are the services. We have to be able to activate it when we want to activate it. In other words, for a user interface, well, when we want to do something with the operating system, we need a way to give that command to the operating system. If we want to work with our files, we have to give it a way to say, I want that file, I want to save that file, I want to open that file. So these are services that the operating system offers. So make sure you know all these different services and what they entail. There's a view of all the different operating systems here. So make sure you look at this and try to get some examples, and, look for examples for each area here. There's GUI, there's batch. Batch is when everything is sent at one time at a scheduled time. Command line. Look for your command line on your computer. What does that mean? That's just where you actually enter operating system commands. You don't click on an icon, or you don't drag or copy something. This is where you actually type it out. This was the first type of interface to operating systems. We've now gotten very graphical now. So this goes through the history of the interfaces. Make sure you do know this. You're going to need all to know about the different ones. There are examples in your textbook. The Bourne shell, that's for your Unix, Linux systems. Here's for your Mac. You have the Windows. You should be familiar with it. Touchscreen devices now is something that all operating systems now need a different set of programs. We need a device driver for the touchscreen. It's not a keyboard. And then when we do programming, when you program, you sometimes have to work with the operating system. This is known as system calls. So you're calling the operating system to do a job for you because you can't physically go ahead and access RAM yourself. You've got to call the operating system to get that value in RAM for you. Or put that information on the hard drive for you. So these are all system calls. Programming languages have, facilities for you to program this in. C and C++ are known as the systems programming language for systems programmers. These are some examples. I'm trying to get through this. API, you should know all about APIs and the reference libraries if you've done Java. Every programming language has a reference library that has all the information for you so that you can use it and then create your program. And then sometimes you need to pass information to a system call so it knows what you need to do and it has the data. So there's strategies that the operating system has to take care of to make sure when you are giving it data or data is being passed that it doesn't lose that data or it goes to the correct place. So we'll be looking at all those strategies. These are the types of the system calls. Here are some examples. Again, if you've done some programming, you've probably seen it already. Any of your read or write statements are system calls. And then system programs are specific ones, just like I mentioned, your antivirus or your screensavers. And here's the list I was mentioning to you. I know there's a lot of material, but I don't want to keep you past the time. But here's a list. I will get you these slides. So here's a list for Chapter 1. Make sure you understand these topics. Here's the one for Chapter 2. Again, it's a great way if you write these out, the information with it, and then when you have the midterm exam, you could use it to review and to study. And do it early. Don't wait until the midterm exam to start looking at these topics. Start early. The sooner you go into the material, then the longer time you have to absorb the material. And then in week 2, we're going to start visiting processes. So is there any questions so far? There's a lot of material, but I hope I helped with it. I hope it was familiar to you. Again, if you didn't read the book or anything, please do. So are there any questions? A lot of material, I know, but if you, again, any questions you have, please bring into the discussions. I can answer them there, or work with your classmates, have a little study group. As we go on, there won't be any, it won't be as much material, so I can have more time for discussions and questions. We pretty much went through some of the key topics of Chapter 2. You are responsible for all of it. I just touched upon the key topics. I believe we kind of went through the key topics here. System boot, I mentioned in the beginning. We kind of went through this. So these are the key topics for Chapter 2. They were briefly mentioned. If you have questions, just put them in the discussion forum or email me. But we only can cover so much in 1 hour. If we're up to me, yes, I'll stay with you all day. But I don't think it's up to me, and I don't know if you could stay with me all day and we could talk about Chapter 1 and Chapter 2. But, again, collaborate with each other. Will have office hours Monday, so we can meet next Monday. We'll start talking about the Week 2 material. But we have until Saturday for Week 1, so anything you want to ask about or know about. There are the videos, there are the PowerPoint presentations that have the complete information from the chapters, and then read the textbook. So hopefully that'll help you. And with that, I'll say have a good day, and I will see you next Monday here in Blackboard Collaborate. If not, and then until then, I will also see you in the discussion. Thank you so much. And don't hesitate with your questions. It's a lot of new material that's, if you're new to this, it can be overwhelming. But believe me, we're going to look at this again and again throughout the entire course. So you'll have time to understand it. And also go ahead on the internet. I did put some extra links in the discussions. So a lot of good information. Okay, thank you and have a good day or evening.